In this video, we're going to talk about account abstraction on ZkSync and how you can create sponsored transactions using Paymasters. Hi, I'm Ed Zynda, and this is What the Funk. Account abstraction has been a hot topic on Ethereum for quite some time now. While some progress has been made with EIPs like 4337, full account abstraction has yet to be realized on the Ethereum mainnet. In this video, I'm going to talk about what account abstraction actually is. We'll talk about EOAs, smart accounts, and how you can take advantage of this UX on ZkSync today. If you're new to the channel, here on What the Funk, we talk about all things Web3, AI, programming, basically anything that gets nerds excited. If that's something that you're into, make sure to hit that subscribe button and click that bell notification icon so you can stay up to date whenever I post a new video. Let's get into it. So real quick, let's talk about how accounts work on Ethereum today. First, you have your EOA, or externally owned account. Then you have your smart contracts. Now, EOAs are controlled by a private key, and they're basically the wallet that you use from day to day when you're interacting on Ethereum. Every EOA has an address tied to its private key. Smart contracts also have an address, but it's not tied to a private key and not controlled by a private key. Smart contracts also hold code. Both EOAs and smart contracts can hold a balance of Ether, and they can both have transactions associated with them. EOAs are the only account that are able to initiate a transaction. Smart contracts cannot initiate transactions themselves, but they can call other smart contracts, and they can send Ether to other smart contracts and other EOAs. So because smart contracts have code associated with them, they can run a number of different arbitrary actions. EOAs, on the other hand, without having any code associated with them, they're not able to do anything arbitrary. So, for example, if you wanted to trade a token on Uniswap and then stake that token into some other platform and then take the IOU tokens associated with staking and do something else with that, with an EOA, you're going to have to do every single step of that in an individual transaction. You may be able to use a smart contract for this, but the way some protocols are designed is that they kind of look for which address is interacting with this protocol, and if the address that's actually calling this protocol happens to be a smart contract, it may or may not work because of the way the contract is coded. So you're not going to be able to do anything super complex with an EOA without some special fudging. Now, one workaround around this is to create what is called a smart account. And a smart account is basically just a smart contract that acts like a wallet or an EOA, but it's still, at the end of the day, just a smart contract. So you would give the smart account some basic functionality to hold balances, display balances, and call contracts, whatever, but it's controlled by an EOA, because remember, only an EOA can initiate transactions. So your smart contract would act as your main wallet address because it has an address associated with it. And then you would do all of your activity through this smart account, but triggered by this EOA. And the EOA would be paying for the gas in this case. Now, this is pretty useful, but not ideal. It would be much better if you could have an EOA with the functionality of a smart contract. Now, there are a number of EIPs in the works for Ethereum to try and bring this into reality, but they're not quite here yet. On ZkSync, however, account abstraction has already been implemented and you can use it today. On ZkSync, every EOA is basically a smart contract under the hood. So you have your EOA, it acts like an EOA. If you're using MetaMask, for example, you won't be able to tell the difference. But under the hood, it's actually a smart contract that can do a number of interesting things. Every account should implement this iAccount interface. I won't go too much into it, but it basically covers all of the logic under the hood for how an EOA operates on ZkSync. You can even deploy what are called custom accounts that implement this interface, and then you can add custom logic overriding these different methods to do some interesting things. And that's something I could probably cover in a later video. Another concept that's been introduced by ZkSync is the concept of a paymaster. A paymaster is a special type of contract that is able to front the cost of gas for a transaction, but it's called through your EOA. For example, if my EOA has 0 ETH, but I want to call a function on another contract, I can use this paymaster to pay the gas for the transaction. So the transaction would appear to be coming from this EOA, but the ETH for this transaction would come from the paymaster. Every paymaster should implement this paymaster interface. And the important method we're going to talk about in this video is the validate and pay for paymaster transaction. Basically, it's going to receive the transaction information, and then it's going to return this bytes for magic, which is basically this. It's just a unique set of bytes that's returned when the paymaster agrees to pay for this transaction. Also, during the course of this function, we will need to pay what is called the bootloader, which is called at the beginning of every transaction, and is going to be keeping tabs on the gas being paid for this transaction. So to demonstrate how this works, we're going to create a paymaster in Remix. So you should go to remix.ethereum.org, go to workspaces. You can create a new workspace. I've already done that. And one thing we're going to need is this ZkSync plugin. You can install it using the plugin manager down here. I've already installed it. All you need to do is search for it and then activate it. And this is what's going to allow us to compile our contract specifically for ZkSync. Now, ZkSync is EVM compatible, but because of all the cool things going on under the hood, it needs to be compiled in a specific way. So let's create a new file. I'm going to call it Paymaster. First thing we need is the pragma and the license identifier. Then let's go ahead and call this contract my Paymaster. Next, we're going to import a few things, and I'll just go ahead and explain everything line by line. First, we're going to import the Paymaster interface, and then this Paymaster validation success magic. That's the bytes that we return on success. Then we're going to import the bootloader address, and this is the address that we actually pay gas fees to. We're going to need this transaction struct because this is how we decode the transaction that's being sent through the Paymaster. And then this Paymaster flow. There are a number of different ways that a Paymaster can be called, and this is through a Paymaster flow. One of the flows is general, which is basically the Paymaster doesn't really expect anything but pays ETH for the transaction. And then the other type of flow is what's called an approval flow, and it's a way for users to compensate the Paymaster for the transaction fee by paying a specific token. So the user would approve an amount of tokens to the Paymaster. Paymaster would pull those tokens in exchange for paying for the transaction. But in this example, we are going to use the general flow. Next, I want to say that my Paymaster is Paymaster. Now we need to implement these functions. First, I want to create a modifier, and this modifier, only bootloader, basically tells ZkSync that I only want the bootloader of ZkSync to be able to call the functions on this Paymaster, because there's really no reason for any other account to call this, because all of these things are managed through the bootloader. So this is just a safety precaution. Next, we need to implement this validate and pay for Paymaster transaction. It's going to take a bytes 32, another bytes 32, and a transaction. The first two parameters we're not really going to deal with in this example because all we care about is the transaction. And then it's going to return the bytes for magic and then the context. First, let's set the magic variable to this value of the constant that we imported earlier. Next, we are going to get the Paymaster input selector. Now, this is what is part of what is called the Paymaster input, and it tells the Paymaster how it should function when paying for this transaction. And this selector is going to tell us what kind of flow that the user expects to use when calling this Paymaster. And we're just going to check that the Paymaster flow is general. Otherwise, we're not going to support this transaction because we don't care about the approval flow. That is another way to pay for a transaction. Next, we need to figure out how much this transaction is going to cost. So in order to figure that out, we're going to take this transaction variable that's passed in, and we're going to get the gas limit, and then we're going to multiply that by the gas price or the max fee per gas. Now that we know how much the call is going to cost, we need to pay the bootloader for this transaction. So we will take the bootloader formal address, we'll do a call with a value of the amount of required ETH, and we're just going to send that to the bootloader. And we just need to make sure that that call succeeds. So we require success. If not, we revert with an error message. And because Solidity supports implicit returns, if you have named return parameters up here, it's going to return these automatically. We don't need to specifically call return down at the end of this function. So we need to implement this post transaction function, which doesn't actually get called in our case. So we can just implement it with an empty function. Finally, we need to add a receive method so that we can send some ETH to this contract so the paymaster can actually pay for gas whenever transactions are going through this. One thing you're absolutely going to need is a withdrawal function if you use this in production. I'm going to be deploying this to the ZkSync Sepolia testnet. So I'm just using testnet ETH. I don't care about it at all. I don't care if I lose any of this ETH because it's not worth anything. But if you're going to deploy this to production, you're going to want to add a withdrawal function so you can get the ETH out of this paymaster if you need it. We're going to send ETH to this contract and it's just going to get stuck there. Next, I'm going to come down to my ZkSync plugin, and then I'm going to compile the Paymaster transaction. It's going to ask me if I'm going to allow it to write to my files. I'm going to say yes, accept. And then before I hit deploy, I want to come down here to where it says environment. I'm going to go to wallet, and then I'm going to connect my MetaMask wallet, which is already connected to the ZkSync Sepolia testnet. And this way, when I hit deploy, I'm going to hit deploy. It's going to ask me in MetaMask. You won't see it on your screen. I'm going to hit sign, and then you can see down here, it's deploying contract Paymaster. I'm just going to wait a few minutes, and you can see in the logs that it has been deployed, and we can see over here in interact that we have a Paymaster transaction, and I'm just going to copy this address, and we're going to be able to use it later. Next thing I'm going to do is I'm going to create a real quick simple store transaction. For the sake of time, I've just copied and pasted this contract here into this simplestore.sol file. And all it is a contract that allows you to change this string in the storage with this set message function. So I'm going to compile and deploy that one as well. I'm up to compile, click compile. Now that it's compiled, I want to make sure to verify this so we can read it later. Deploy and verify. I'm going to sign this off screen. And if we go down to interact, we can see that this has been deployed. I'm going to copy this, and we're going to use this later as well. Now over in my terminal, I've created a brand new directory called ZkSync Paymaster. And we're just going to create a real quick script to call a function on this simple store contract and use a paymaster. In this case, I'm going to use bun. You can use node if you like, but I prefer bun. I think it's awesome, cool, and I'm kind of a hipster that way. We're just going to run bun init. Just go through all the default stuff. All right. And then we're going to install a few packages. We're going to install ZkSync Ethers and Ethers version 6. With that installed, I'm going to open index.ts in my editor. We can get rid of this console log and let's start building. Let's import a few things we're going to need below. Next, we're going to create a provider, and we can get a default provider that connects to the ZkSync Sepolia testnet using this. So with the ZkSync, we're going to need a provider for the ZkSync network plus a provider for Ethereum mainnet. So we create both of them below. Connecting to Sepolia testnet, I'm going to pull a private key from my environment variables, and then I'm going to use that private key plus these two providers to create a new wallet to run transactions. Next, I'm going to add my Paymaster address and then the simple store address. Then I'm going to define an API. This is going to allow us to communicate with the simple store contract. Next, let's create a main function. Then let's console log a few things. So we're going to show the paymaster balance before this transaction, the wallet address, and then the wallet balance before the transaction. Next, let's go ahead and construct the transaction. If you're familiar with constructing transactions using ethers on Ethereum, this may look a little bit different to you, but this is how we need to construct our transaction on ZkSync. So we're going to give it a type. It's going to be an EIP 712 transaction type. So basically, instead of sending a actual transaction to the chain, we're going to be signing a message, an EIP 712 message, and this signature gives the paymaster permission to run the transaction on our behalf and pay the gas fees. So we're going to send the transaction to the simple store address, and then we're going to call the set message function with the message hello ZkSync. And then we've got this custom data section. So we are going to set this gas per pub data parameter, and we're just going to use the default. And then what's important here is this paymaster params, and we need to encode this in a specific way. Thankfully, there's a utility function included in the ZkSync ethers package to do this for us. So we call this get paymaster params function. We set the paymaster, which is the paymaster address. We're going to use the general paymaster flow and this inner input data, which we are not going to use. So this is basically the simplest paymaster flow you can use. So we're going to send this transaction, which is basically sending a signature, and then we're going to wait for this transaction to finish. Finally, after everything has finished, we're just going to console log the paymaster balance and the balance of our wallet. And in order for this to work, we need to actually call this main function we defined above. We're gonna catch any errors and display those, and that's it. Now, there are a few things we need to do before we can actually run this transaction. The most important thing is we need to give some ether to our paymaster. If I check with the cast command provided from Foundry, I can see that my balance on the paymaster is 0. So I'm going to quickly send some ETH to that paymaster. Now, if we check again, I've got a little bit of ether. Next, I'm going to generate a brand new wallet that has absolutely 0 ETH. You can do that using the cast command as well, and the command wallet new. And so I've created a brand new address. This is the private key. Feel free to use this private key. I'm not going to use this address ever again after this video, so do whatever you like. Again, if we check the balance of this brand new wallet, we can see that it has 0 ETH. And this is the wallet we're going to run transactions for, but using the paymaster to pay for gas. Now I've gone ahead and added that private key into the private key environment variable. So now it's the wallet we're going to use for our demonstration. Now, if we run bun index.ts, we can see the paymaster balance before the transaction, our wallet address, which is the one we just freshly created, the balance before the transaction, and then the paymaster balance. So it looks like it actually used a little bit of gas to pay for this transaction. And we can see that the balance of the wallet after the transaction is still 0. Now, if we go back to the browser and go to the Explorer for ZkSync on the Sepolia testnet, we can have a look at this transaction that ran through our wallet. We can see that we still have no balances. Let's click into the transaction hash. We can see that it called the set message function with the parameters hello ZkSync. And then we can see over here that this fee was paid by the paymaster. And then we can see that the paymaster is the same address that we deployed earlier. And if we go to this contract address, we click on contract, read, and then query the message, we can see that the message is hello ZkSync. Now we can try this one more time. I'm going to create a brand new wallet again, brand new address, brand new private key. Back in our code, I'm just going to change the message to something different. We're going to say what the funk. We're going to run this transaction again. Again, you can see it's running through a different wallet address. You can see that the balance in the paymaster has changed a little bit after the transaction. Back in our browser in the Explorer, we can see another no balance wallet, but it has a transaction. You can scroll down and see that it called the set message function again with what the funk. And if we go back to this contract, click on read message, it says what the funk. And both of these wallets did this without having any ETH to pay for gas. And that's it. That's how easy it is to create sponsored transactions on ZkSync using their built-in account abstraction. If you enjoyed this video, make sure to smash that like button. If you have any comments or questions, leave them down below. Once again, thanks for watching, and I'll see you in the next video.